Okay, well, based on this example of what we do with numerical fractions, we find a common denominator, okay? So in the case of numerical fractions, denominators are 8 and 7. Well, the least common denominator of 8 and 7 is 8 times 7, because 8 and 7 have no common factors. So we can simply multiply the numerator denominator 5/8 by 7 over 7, which doesn't change the value of the fraction, it just changes the way it's presented. And then we can take the second one and multiply it by 8 over 8, and now we see that the denominator is going to be 8 times 7 here, and 7 times 8, which is the same as 8 times 7 here. They have the same denominator, so now we can add numerators. Now, before I do that, I'm going to go ahead and do the arithmetic. We get 35 over 56 plus 16 over 56. And that equals 71 over 56. So 71 has no divisors, so that this fraction is not going to reduce. Well, that's the process, and we follow a very similar process. Here, we got 1 over x minus 3 plus 3 over x plus 5 over here. We do 1 over x minus 3 multiplied by x plus 5 over x plus 5 plus 3 over x plus 5 multiplied by x minus 3 over x minus 3. And now we have the same denominator, x minus 3 times x plus 5. And of course, this one will be x plus 5 times x minus 3, which is the same. If we were to multiply this out, we get x plus 5. Multiply each of these out over x squared plus 2x minus 15. Now, usually I'm not going to multiply the two denominators out, but I'm doing it now just to emphasize that we get the same denominator. We usually want to keep the denominator factor because at the end, we want to simplify our expression. And anyhow, then we get 3x minus 9 over x squared plus 2x minus 15. Same denominator. So now we can simply add numerators and express them over the same denominator, x plus 5 plus 3x minus 9 over x squared plus 2x minus 15. And then we simplify our numerator. X and 3x give us 4x. 5 and negative 9 give us negative 4. And the denominator is x squared plus 2x minus 15. There's one example. Now, something slightly different is going to happen in this example. The board's visible. Okay. Next problem was 2x over 4 minus 6 over x plus 7. Well, the common denominator is going to be 4 times x plus 7. You express this sum so that both terms are in the same, have the same denominator. You're going to have to multiply 2x over 4 by x plus 7 over x plus 7. And then x6 over x plus 7 will be multiplied by 4 over 4. Then our denominator is going to be 4 times x plus 7, or x plus 7 times 4, same thing. So we can now express this. We can multiply this out. Multiply 2x by x plus 7, we get 2x squared plus 14x. And that's over 4x plus 28, because when we multiply 4 by x plus 7, 4 times x gives us 4x, and 4 times 7 gives us 28. Then it's going to be minus 24 because 6 times 4 is 24. And x plus 7 times 4 would be x times 4, which is 4x. And 7 times 4, which is 28. And we see that we have the same denominator. So now we can write our expression as follows. Numerator minus this numerator. Now, let's see. That almost factors, but not quite. So the thing we want to do is, at this point, we would want to try to factor this numerator and see if it has any factors in common with the denominator. It doesn't, so we're not going to illustrate that right now, but that's something that we're going to do. And some upcoming examples. Okay, let's do one more. Okay, well, the common denominator is going to have x minus 2, it's going to have x plus 5, and it's going to have x plus 1. To get that, we take the first term, and we multiply it by x plus 1 over x plus 1. So that the denominator will have all three factors. Then we do the same with the second term. We multiply by whatever is going to give us all three of these factors in the denominator. Well, we've got the x plus 1. We need an x minus 2 and an x plus 5. If we now add our numerators with them over the common denominator, we get x plus 3 times x plus 1 plus x minus 4 times x minus 2 times x plus 5, all divided by x minus 2 times x plus 5 times x plus 1. And at this stage, I'm going to say there's more to do, but I'm just going to say equals, etc. We need to multiply these out and try to factor them and everything. And we're not at the point where we can do that, but we are at the point where we can see what the common denominator has to be and multiply each fraction, numerator and denominator, by whatever it takes to make the denominators the same. And what we've seen should motivate the idea that if we end up with a fraction like this after adding two rational expressions, then what we need to do is see if there are any common factors to the numerator and denominator. So let me just ask, give you a couple of minutes. Can you factor the numerator and can you factor the denominator? Write down the numerator, see if you can factor it. Okay, so you did pretty well with this one. Make sure we agree. Numerator factors into x plus 2 times x minus 3. And I think what everybody got was the denominator. And I'll bet you, like x plus 2 times x plus 3. Do you agree? Yeah, very good. Very good. Okay. Now you notice that we've got an x plus 2 here and an x plus 2 here. So we could write this as x plus 2 over x plus 2 multiplied by x minus 3 over x plus 3. You agree if we were to multiply this out, we would end up with this, right? You know, this times this gives us this times this gives us this. Now, of course, what's x plus 2 divided by x plus 2? Can you show me with your fingers what's x plus 2 divided by x plus 2? No. If you divide something by itself, what do you get? You can't divide that in your calculator, but I mean, it's a good thing to try. If you divide something by itself, you get 1. Okay, so good. How many of these does it take to make this? 1. Okay. It was 1 times x minus 3 over x plus 3. It's just x minus 3 over x plus 3, because anytime you multiply 1 by something, you get that thing. Well, let me give you another one. This, factor the numerator, factor the denominator, and see what you get. Okay, so x squared plus x minus 20. Well, that gives you x plus 4 times x minus 5. X squared minus 7x. I'm sorry, that gives you x minus 4 and x plus 5. X squared minus 7x plus 12 is x minus 4 times x minus 3. And of course, the same thing that happened over here is going to happen here. You got x minus 4 over x minus 4 multiplied by x plus 5 over x plus 5. And x minus 4 over x minus 4 is 1. And when you multiply 1 by this expression, you just get that expression. Okay, so let's see what you would get if you multiplied these two fractions. To see what you would get, you want to factor everything you can. Now we just factored this one and we just factored this one, so we know that this one's going to be x minus 3 times x plus 2. And this one's going to be x plus 2 times x plus 3. And this one's going to be x plus 5 times x minus 4 over x minus 4 times x minus 3. So if I multiply these together, you're going to get this for my numerator because we just multiply the numerators. And then we multiply our denominators. Now what we see is that we have an x minus 3 here and an x minus 3 here. So we could bring that out here. We just say, okay, we're going to do x minus 3 over x minus 3 times a bunch of other stuff. That'll still give us the same numerator and the same denominator. And also notice we have two x minus 4s. So it's kind of like, I'm going to just put a light line through the x minus 3 because open math is going to tell you to cancel these things. I don't like that. But I won't say I don't like that. I like a lot of most of what open math does, but I don't like cancellation because people always do it wrong. Okay. So, but I'm going to kind of lightly draw a line through these so we know we've taken care of them. We know this is over here. We know this is over here. And we also know that this divided by this is the same as this divided by this. That's just going to give us 1. And the x minus 4 divided by the x minus 4 is going to give us 1. Then we have I didn't even see it. Makes things easier. Okay, well, we also have an x plus 2 here and an x plus 2 here. Then we have this whole string of things. And then we have an x plus 5 and x plus 3. And every one of these in the string, the numerator matches the denominator. So all these are 1. And we finally get x plus 5 over x plus 3. Now, just to test this, because we want to get in the habit of checking things, how about if we let x equal 2? And replace x, all the x's up here by 2, and replace all the x's down here by 2. Okay, first, if you take x plus 5 over x plus 3 and replace the x's by 2, what do you get? I'm going to check this. Okay. Replace x by 2, what do you get? Okay. Let x equal 2, x plus 5 over x plus 3. Well, x is 2, so you replace x by 2, you get 2 plus 5, the numerator, and 2 plus 3 for the denominator, which is 7 over 5. Now, if this has been done right, if you plug 2 in for the numerator for x everywhere here, you should end up with something that gives you 7/5. Okay. Now it might be, 35 over 25, or 70 over 50, or just about anything. Now, when I do this, I don't see anything wrong with what I did here. I've been over 2 or 3 times. It doesn't check out, at least when I do this in my head. So follow me. If x is 2, x squared is 4. So we have 4 minus 2, which is 2. 2 minus 6 is negative 4. Over here, we've got 4 plus 2, which is 6 minus 20 is negative 14. And negative 4 times negative 14 is positive 56. So I'm saying I get 56 here. In the denominator, I get 4 here and 10. Oh, that's what I did wrong. Okay. 4 here and 10 here, which is 14. We add 6, we have 20. Okay. 4 then minus 14 plus 12 is 2. And 20 times 2 is 40. When I was doing this in my head, I squared x to get 4, and then instead of multiplying 5 by 2, I multiplied 5 by 4 because my head isn't working perfectly, which is something everybody's used to. Okay, anyhow, 56 over 40 reduces 7/5. There it is. There it is. So that checks. So we want to get in the habit of checking things. But yeah, very good. Okay. Talking about least common multiple. Consider the two expressions, x squared plus 5x plus 6 and x squared minus x minus 6. The factor forms of these expressions, well, we just factor them. We know that these are the factors. X plus 2 times x plus 3 gives you this. X minus 3 times x plus 2 gives you this. A common multiple of these two expressions, you just multiply this one by this one. And that's a common multiple because this expression is contained right here. And this expression is contained right here. So that this expression down here, our common multiple, well, what have we multiplied by x plus 2 times x plus 3? We multiplied it by x minus 3 times x plus 2. So this is a multiple of this. And what would we multiply x minus 3 times x plus 2 by? We'd have to multiply it by x plus 2 times x plus 3 to get this common multiple. Well, that might or might not be clear. I might or might not be sorry I said it that way, but there it is. Okay. Now, here's a lesser common multiple. It contains this, doesn't it? But there it is. Does it contain this? Well, yes, it contains this. Of course, I haven't written it. In an order where I can put these together. We can't always do that. But if I circle this and this, I've got this, right? So this is hiding right there. And the blue one is right here inside the blue circle, staring you in the face. Okay. You got to kind of look for this when it's hiding, but there it is. Okay. Now, the reason we can do a lesser common multiple is both of these have x plus 2 in them. And we don't need x plus 2 twice to contain this. We just need one x plus 2. Or to contain this, we just need one x plus 2. Okay. So this is what we need. Now, these two don't have any more common terms. So we can't go any less than this. Okay. There's no lesser common multiple. This is the least common. It's the one thing that has everything you need and nothing extra. It has everything you need. I'll say it contains every factor of both expressions. And nothing more. Okay, this is not a least common multiple because one of these x plus 2's isn't needed. That's the idea of a least common multiple. If we were adding two rational expressions with these denominators, I haven't left myself room. And if there's something written kind of right in the middle of this page, there's board. Well, let's just do this. Got a whole way, and I got plenty of boards behind it. Okay. Now let's use that idea. See what I got. Make sure I can see the whole board. There we go. Let's add these two. Okay. Well, factor. I'll say factor things. You know, I mean factor everything. It can be factored. Okay. Least common multiple of these two denominators, because these denominators in factored form match these expressions. So from what we've seen here, least common denominator is the least common multiple of these two denominators. So that means the least common denominator is this least common multiple. It's this. So once we've found the least common denominator, which is the least common multiple of our denominators, we should be able to identify what we need to multiply numerator and denominator on each of these terms. So we could write x minus 5 over x minus 3 times x plus 2 multiplied by something over something. And then it's going to be plus 2x plus 7 over x plus 2 times x plus 3 plus, again, something over something. Okay. Now this is going to be a rational or fractional term, and so is this, but I don't yet know what I'm going to put in the numerator and denominator. So I'm going to leave the question to you now. What more do I need in this denominator to get this to the denominator? What do I need to multiply this denominator by to get this? That's going to go here. And what do I need to multiply this denominator by? Should we put a plus there? What do I need to multiply this denominator by to get my least common denominator? So here's a denominator we want to get. Here are the denominators we have. See what you can do. Okay, so that was pretty good. Not everybody had it written down right, but as soon as I pointed it out, everybody nailed it. Okay, so here's what we asked. We need this, this, and this. What have we got? We've got x minus 3. We've got x plus 2, but we don't have x plus 3. So we need x plus 3. And of course, and everybody knows, at least everybody that's here knows that it's got to be x plus 3 over x plus 3. And then x plus 2 times x plus 3. What's missing? Well, we got the x plus 2, we got the x plus 3, we don't have the x minus 3, so we got the x minus 3. Having done that, we can write this out as x minus 5 times x plus 3 plus 2x plus 7 times x minus 3, all divided by x minus 3 times x plus 2 times x plus 3. So this equals this, because all we've done is multiply each fraction by 1. They're actually rational expressions. It's quicker to say fraction. I think we know what I mean. And down here, we need to just multiply everything out. We have x squared minus 2x minus 6 plus 2x squared minus 6x plus 7x minus 21 over same denominator we had before. And now we can collect our like terms. We have a minus 6 and a minus 21, which is going to give us a minus 27. And we have a minus 2x, a minus 6x, and a plus 7x, which gives us plus x. And then we have 3x squared. That's all over x minus 3 times x plus 2 times x plus 3. Now, by the magic of the quadratic formula of discriminant, which we haven't talked about yet, but will in a couple of weeks, I can determine whether this is going to factor. So this is just mysterious, but you got 81 and 1 is 82. The square root of 82 is irrational. So this doesn't factor. You don't have to understand what I just said. It's that simple. Once you understand what the quadratic formula tells you. So that's something to look forward to in a couple of weeks. Okay, so that's it. Now, if we wish, we can multiply out the denominator. Just use the distributive law a couple of times, and that multiplies out.